In this tutorial video, we are going to look at the graphical representation of linear motion. All right. So, when we're looking at the definitions, we talked about this to be constant acceleration. Okay. So, having this as velocity and having this as time, what we know is, let me just reduce that. It is starting from 0, and if a car starts from 0, it's going to move. Remember, this is time, this is velocity. So if it reaches, let's say 15, that is going to be 15 meters per second. Okay, so the car moves from 0, from the velocity of 0, and reaches 15 meters per second. In what time? Let's say in 2 seconds. Remember, this is time, this is velocity. So this one shows us that this car is moving with a uniform acceleration. And it's moving with a uniform acceleration from 0 to 15 in 2 seconds. Then it can continue with the same velocity for another 2 seconds. Now, if it continues for another 2 seconds, then time becomes 4, because we are going to add that 2 seconds to this 2, so this becomes 4. Before it comes to rest in, let's say, another 6 seconds, which will make it 10. So this is almost a full representation of linear motion graphically. So we have got uniform acceleration, constant velocity. Why is it constant velocity? Because when the car is moving in this space of 2 seconds, the velocity is not changing, it is always 15. Then it begins coming down until it reaches the velocity of 0 in 10 seconds from start. So it begins decelerating here. So if I can classify this, I'm going to say A, B, and C. In A, the car is moving with the constant acceleration from 0 to 15 meters per second. Then it is going to maintain that 15 meters per second up to this point. 15 meters per second, that is constant velocity. Then it begins decelerating or coming to rest in region C. This is what we said, it is a deceleration or retardation. So now, there are a few things that you need to understand here. It is very easy for you to find the acceleration here, because we're just going to say acceleration is equal to final velocity minus initial velocity over time. Now, final velocity in region A is 15, because the car started from 0 and it reached 15. You get it? So this becomes 15 this 15 becomes the final velocity, and the 0 becomes the initial velocity. So this is going to give you 15 minus 0 over the time is 2 seconds. So that becomes 7.5 meters per second squared. Okay, so that is region A. In region C, you can find the deceleration by saying acceleration is equal to final velocity minus initial velocity over time. Now, here it's very tricky. You need to know that this car is moving from this point. It's moving from this point going there to that point, okay? So in short, it's moving from 15 coming to 0, because it's going to rest. So the final velocity is 0, because it ended at 0 here. You get the point? It ended at 0. So it's from 15 coming to 0. So the final velocity is 0, because that's where it reached. Then it started from 0. It started from 15, which is the initial velocity. Then time interval is from 4 to 10, which is 6. So this becomes 15 divided by 6, which should give us 15 divided by 6, 2.5 meters per second squared. And remember, this is negative. That's why we define the deceleration to be simply the opposite of acceleration. So here it is very simple. Here it's very tricky. Remember always where it is starting and where it's ending. In this region, always the initial velocity will be bigger than the final velocity. That is another trick. Now, when we want to find the distance that has been traveled by the car, there are two methods. Number one, if you look at this, these are regions. There's region A, region B, region C. Region A is a triangle. If you look at it, it's a triangle. Region B is a rectangle. Region C is another triangle. The distance traveled by the car in a graphical question like this is equal to the area under the graph. In the area tutorial, we're using the equation AC is equal to UT plus half AT squared, V squared is equal to U squared plus C 2AS. But here, the distance traveled by the car is equal to the area under the graph. So I can find the area for for A, I find the area for B, I find the area for C. Okay? Then I sum the total area. That will give me the total distance traveled by the car. If I'm asked to find the distance traveled by the car during constant acceleration, all I'm going to do is find the distance in region A, because this is where there is constant acceleration or uniform acceleration. If I am asked to find the distance covered by the car during constant velocity, I'm just going to find the area for this triangle in between. If I am asked to find the distance traveled by the car during deceleration, I'm only going to find the area for C. So let's do that. Area for A, area is equal to, it's a triangle, half BH. Half times B, it's from here to here, which is 2, times height, it's from here to there, which is 15. So the answer becomes 15 meters. You see it? Then for B is a rectangle, so area is equal to L times B, which is, we have got the distance from here to there, which is 2 times 15, which is height. Then the answer becomes 30 meters. Then for C, okay, area is again a triangle. So half BH, which is half multiplied by distance from here to here, it's 6 times 15. Okay, so that is 3. So area is equal to 45. So the total area, I'm going to write it down here because you guys are copying down the notes. You can just pause the video and copy down. So the total distance covered, I want to use AC because we have been using AC, is equal to 15 plus 30 plus 45. So just pick up your calculator and find out this. Of course, this is supposed to give you 60, that should give you 90. So the answer should give you somewhere 90. Okay, so let me see if you find the correct thing in the comment section. Now, that is the method 1. Method 2 is simply looking at the entire area. You can tell that this is a trapezium. And with a trapezium, this is A, this is B. So remember the formula for finding the area of a trapezium. Area is equal to half A plus B multiplied by H. We said area is equal to half A plus B multiplied by H. If you don't know this, you can visit your mathematics book. Okay, so A, it's from here to here, which is 2. B is from 0 to 10, and our height is 15. So just punch that into your calculator. So for simplicity purpose, this becomes 12, that becomes 15, this becomes 6. Okay, so 15 by 6, that should give you 90, because you have 30, 60, 90. So you see that the distance becomes the same. So please notice the few things that we have talked about. How to draw the velocity time graph, how to find acceleration, how to find deceleration, how to find the distance in each region. Now, sometimes the examiners become tricky. They can ask you to find acceleration in B. Acceleration is 0 because in region B, velocity is not changing. So if you say acceleration is equal to final velocity minus initial velocity over time, final velocity is 15. Initial velocity is 15. That becomes 0. So there is no acceleration in region B. You need to know that. Let's meet in the next tutorial.